In this video, I'll show you how to use Excel to find the exponential distribution. So here we are on the Chapter 6 Excel Resources file, and I'm going to be working in this section here where it says exponential distribution. Normal distribution is just above, but this video will focus on exponential. So let me go ahead and zoom in a little bit just to make it a little bit easier. Now recall in Excel that Excel always reads left to right. So that's how we've set up my formulas here in order. And if you forget, you can always read the notes here that remind you which formulas apply. So here we've got exponential distribution, and I've got a note here in bright red to remind you how to find the lambda. And the lambda is just 1 divided by our mean. Whatever our average or mean is in the story, we throw that in the bottom or the denominator of this formula, 1 over mean. Okay? Because that lambda is going to go into whichever formula you need. Now, anytime you're doing a less than scenario, we're going to use this first formula here, equals exponential.dist, and then we'll plug in our x, our lambda, and true. Because it is cumulative, we're adding up all the probabilities under the curve, and so that's why it's always going to be true. Notice I don't even have false listed anywhere on this screen or on this worksheet. The next line here is anytime we're working with a greater than scenario, and this applies in all the chapters, anytime it's a greater than scenario, it's always 1 minus the formula. And that's because Excel only knows how to read left to right, but when we're trying to do greater than, we're trying to get the right side of a data point. And so the 1 minus is the complement rule, 1 being the entire curve, and then we're subtracting the first part of the left side in order to get the right side, the greater than side of a particular x. Now, the third option here is when we're looking for the probability between two x's. So that's why you see the exponent.dist twice, and then there's a subtraction symbol in between. So we're subtracting the two probabilities together because they overlap. Now, again, as a reminder, down in the notes, I remind you to find all values less than or equal to a particular number, like x is less than 3, or x is less than or equal to 3, use the formula where cumulative says true. So just use the formula as you see it and make sure it's got the true in it. So that's this one right here. My other note, to find all values greater than or equal to x, so there's my greater than symbol. For instance, if you were interested in x is greater or equal to 3, then use 1 minus the formula and make sure that cumulative is true. So that's my 1 minus. Now, for some folks, the formulas can be a little confusing, so that's why over here on the right, I do offer the examples from the lecture as a reminder. So you can see here's a question, and the formula I would use to answer this is that one right there. Or here's another question, and that's the formula I'd use for that. And there's another question, because sometimes it's easier to understand when you see an example than just seeing an abstract formula. So in this example from the lecture, according to a website, the average cost of a stay in a hospital for a particular region was $13,000. Assume that this cost is exponentially distributed. So that's how you know we're doing exponential. And we first want to find our lambda. So I'm just going to plug it right here. My lambda is essentially 1. I'm just doing equals. Anytime you do a formula in Excel, you have to put that equal sign so it knows it's doing math. 1 divided by 13,000, because that's my average or my mean in the story. Now I'm just doing this just so you can see it. It's put in a decimal format, but when we type in the formulas here, you have the option. You could write it as decimal or you could write it as a fraction. I prefer as a fraction because then Excel does the math for me, but just so you know what I was doing here, let me just double click on that so you can see the formula again. I just did 1 over the mean, and you can leave it in that format. It's totally fine. So here in this example, what is the probability that a randomly selected patient's stay in a hospital will cost less than $8,100? So that less is the clue that I'm going to use this formula, because that's for less than, we just use the formula as we see it. So exponent dot dist parentheses. The x is the thing I'm trying to solve for, so 8,100, comma. The lambda, recall 1 over the mean. So I can type in the decimal here, or I could just do 1 over divide by slash, however you call it, 13,000, and then comma true. and then closing parentheses, and you can see what I've put in there. When you're ready, you hit enter. And it's 0.4637 or 46.37% chance that a randomly selected patient's stay at a hospital will cost less than $8,100. Let's do the next one. What is the probability that a randomly selected patient's stay in a hospital will cost more than $13,400? Again, they're just picking a number that they want you to solve for. So this is more than. Anytime it's more, that means greater, and greater means I got to do 1 minus the exponent.dist. So I'll do equals 1 minus exponent.dist, parentheses. The x I'm now trying to solve for is this 13,400, comma. My lambda is still the same. It's that 1 over 13,000. And you might ask, where'd that 13,000 come from again? Again, it's in the story here. That was the average cost, comma, and then true. So I'll type in true, close parentheses, and whenever you're ready, you can hit enter. And it's 0.3567 or 35.67% chance that a patient's stay at the hospital will cost more than $13,400. Now, here's the last example. What's the probability that a randomly selected patient's stay in the hospital will cost between, that's your clue, that we're working with two x's, the word between, 9,000 and 10,000. So we're going to find our double formula of exponent.dist, and I'll type in equals exponent.dist, parentheses. Now here's the thing, because I'm working with two x's, we always put the bigger x first. So I'm going to put the 10,000 first, because if you forget and you don't put the bigger number, what you're going to end up with is a negative probability. And we can't have negative probabilities, no such thing as negative 10%. So just make sure if you accidentally switch the numbers and you see that negative, you can just remove the negative, like ignore it, right? The number's still good, but just ignore the negative. So there's my x of 10,000. My lambda is still 1 over 13,000 and true, comma true, close parentheses. Then I'm going to do minus right there because it says minus. And then I got to do it all over again. Exponent.dist, parentheses, and the smaller x, which was the 9,000. Remember, I want to know between 9,000 and 10,000, comma. My lambda is still 1 over 13,000. That hasn't changed. And comma true. And whenever you're ready, double check your numbers. Make sure you have the right number of zeros in there. You're not missing one. You don't have an extra one. And then you can hit enter. And I get 0.0371%. So a very tiny chance, 3.71% chance that the bill is going to be between $9,000 and $10,000. Let me point out one more thing just in case, because I don't want anyone to make this mistake. I'm just going to click on this one real quick. So you see here we've got our numbers of 8,100 and 13,000. Make sure when you type in a number like that, you don't add any extra commas. Like don't do 8,100 because that's going to confuse Excel, because the comma is used to separate the variables that go into the formula. So if you put extra commas in there for formatting purposes with the thousands, it's not going to work. So just be careful of that. Only use the commas where you're supposed to within the formula, which is to separate like the x to the lambda to the true. So if you have any questions, just let me know.